Lithium-ion batteries are great. They power much of the world around us and in our pockets. But trying to scale the technology up for the grid and storing massive amounts of renewable energy is challenging. Limited battery cell supply and manufacturing, difficulty supplying enough rare earth metals and minerals to make the lithium-ion cells, and questions around longevity. But what if there was another way? A method that used air to store energy. This could change everything.
I've been working on this project for about a year and a half now at IBM, and the motivation behind this is the U.S.'s enormous dependence on oil, especially for transportation. Certainly if we want to get away from using oil in the transportation sector, we want to use alternative energy sources.
Specific charge density is the amount of energy a specific measurement of surface area, unit length, or volume can hold. Therefore, a material with a higher specific charge density can hold more energy with the given unit of measurement.
Lead-acid batteries have an energy density of around 40 Wh per kilogram, and lithium-ion has substantially higher, around 120 Wh per kilogram. But if you look at lithium air, this has substantially higher compared to that of any other battery system. For example, in this case, this figure clearly shows that at around 1700 Wh per kilogram.
This is a more detailed illustration of the lithium-oxygen battery. The anode is made out of lithium ions, while cathode is made of graphene with a membrane that allows oxygen to enter. Lithium ions and oxygen meet at the cathode to form lithium oxide when charged and break apart when discharged. As mentioned before, the energy density of lithium-oxygen batteries are significantly higher than those of other batteries. However, the challenge arises when air other than oxygen are present, such as in our atmosphere. When lithium reacts with other gases such as carbon dioxide and water vapor, unfavorable products are formed. When carbon dioxide is present, lithium carbonate is formed, which is solid. When water vapor is present, lithium hydroxide is formed as a solid as well. This is an issue because these solids deposit on the anode and the cathode of the battery, which damage the battery over time. While maintaining the energy density, the battery must be durable to be application in transportation vehicles. A numerical method to measure the durability is by determining the battery life cycle. Life cycle is the amount of charging and discharging cycles a battery can go through while maintaining a high energy density. 600 life cycles are considered successful for a vehicle to travel 500 kilometers before recharging. However, in a research study led by Dr. Amin Salehi Kojin and Dr. Larry Curtis at Illinois Tech, a battery with 700 life cycles was produced with other gases present. This was achieved by adding a molybdenum disulfide protective layer on the cathode to prevent the solids from depositing. Likewise, much progress has been made by researching different buildup of lithium-oxygen batteries. There has been an increase in interest on lithium-oxygen batteries, and hopefully soon the world will revolutionize to renewable and efficient transportation vehicles.